It's about a star, the 10th brightest star in the night sky. It has a name that I'm not going to be brave enough to try and pronounce, but
The biggest and brightest stars in the night sky vanished momentarily as an asteroid passed right in front of it.
Very, very surprising. Now we know that Betelgeuse has a 420-day period.
This created a one-of-a-kind eclipse. The star is Betelgeuse.
There's a massive star, Betelgeuse, in the Orion constellation. It's starting to lose its light. Once bright and massive, burning for millions of years, it's now running low on fuel and could soon explode in a rare, spectacular supernova. Why is NASA terrified to expose the truth behind the entity darkening Betelgeuse? Join us as we reveal the alien reason why the brightest light in our universe is dying. The supernova that could illuminate our past. Betelgeuse has always been interesting to those who study the stars because of their size and their role in our understanding of how stars live and die. If Betelgeuse were to explode as a supernova, it would give scientists a close-up view of these rare and important events. Since it's relatively close to Earth and easy to see, it would allow scientists to observe and study what happens when a star explodes and how it affects the space around it. The star's end is not just a fascinating show in the sky. It's also a chance for scientists to learn more about stars and the universe. By studying how Betelgeuse changes and eventually explodes, scientists can learn more about how elements that make up planets and even life itself are created and spread through space. This could help us understand more about where we come from and how the universe works. As Betelgeuse dims and prepares for its final moments, it also helps us think about bigger questions. How do stars like our sun live and die? What happens when they do? The answers to these questions can teach us a lot about our own planet, and maybe even about how to find other planets where life might exist. So while the star's death might just seem like a distant and beautiful event, it's actually a very important one for science, helping us unlock much of the universe. The light that lets us see this massive star has traveled across space for about 725 years. That means the light from Betelgeuse that reaches us today started during the times of the early Renaissance. So when we gaze upon Betelgeuse, we're actually looking at light that's been traveling through space for centuries. The star's unique behavior also found its way into cultural stories, particularly with the indigenous people from the Great Victoria Desert in South Australia. They integrated Betelgeuse into their storytelling, perhaps as a way to make sense of its erratic nature. Betelgeuse's changes in brightness are a reminder of the dynamic, ever-changing nature of the universe. It's not just a point of scientific interest, it challenges our understanding of how stars behave. This star acts as a bridge between the ancient world and today, linking past civilizations who observed it without any modern tools to contemporary astronomers, who use advanced telescopes to study its every shift. As ordinary people, our fascination with Betelgeuse might stem from our desire to connect with something larger than life, to feel a part of the grand workings of the cosmos. Each time we look up at that star, we're participating in a tradition of observation that spans centuries, involving countless individuals trying to decipher the rhythm of a star that doesn't seem to follow any rhythm at all. Every glance we take at Betelgeuse is a mix of scientific inquiry and a touch of poetic reflection. It reminds us that while we strive to understand the universe with our theories and models, the cosmos often moves in ways that are beyond our simple comprehension, continuing its dance whether we're watching or not. As one star sparks our curiosity, another prepares for a grand cosmic event. From neutron stars to gamma-ray bursts, Richard Hinckley Allen, an avid stargazer from the 19th century, connected Betelgeuse to Rudra, a god associated with storms, as described in ancient Vedic texts. This link, perhaps a stretch of the imagination, tries to align the turbulent nature of the star with the tempestuous personality of a god. Betelgeuse's shift from bright yellow to its current red hue has captured human imagination, leading to its inclusion in many cultural tales that aim to give more human-like qualities to these distant lights. Yet in late 2019, something unusual happened with Betelgeuse. It started to dim noticeably. This change sparked conversations and concerns about the star possibly exploding soon in a supernova, a significant event both scientifically and symbolically. While a supernova would be a monumental event for astronomers, culturally it resonates as a symbol of change or even doom. Such interpretations of Betelgeuse illustrate how people have long looked to the stars to find reflections of their own lives and beliefs. The star has stood as a fixed point in human culture, a beacon in the stories that we tell about our universe and ourselves. Whether as a lion, a severed limb, or a chief's lost arm, Betelgeuse has woven itself into the fabric of human myth, serving as a celestial anchor for our earthly concerns and curiosities. These narratives not only enrich our understanding of the cosmos, but also connect us more deeply with our ancestors, who first named these stars and told their tales. As Betelgeuse continues to fascinate and puzzle us with its changes, it reminds us of our perpetual quest to understand the universe and our place within it. Through these stories, both old and new, Betelgeuse remains a powerful symbol in the night sky, linking us to the wider cosmos and the puzzles it holds. The universe is a massive stage where stars perform their life cycles, culminating in the most dramatic fashion possible, supernovae. These celestial events are not just spectacular shows of light and energy, but also critical in shaping the cosmos. One of the standout supernovae that astronomers have studied up close is SN 1987A. It's special because it was one of the first where researchers could actually see signs of a neutron star forming right at the heart of the exploded star. This supernova showed us how some stars end their lives by transforming into incredibly dense neutron stars, surrounded by a colorful display of materials that once made up the star itself. Then there's Cassiopeia A, or Cas A, which serves as a sort of time capsule in the sky. This supernova remnant glows with the light of materials like sulfur and oxygen, creating a visual spectacle that tells scientists a lot about what happens after a star explodes. The colors and structures in these remnants help scientists understand how the elements that make up everything in our universe, from planets to people, are recycled over millennia. More recently, astronomers have been keeping their eyes on SN 2023 IXF, a new star on the cosmic scene. Located in a galaxy that's relatively close to us, this supernova has been a boon for both professional astronomers and backyard stargazers. Its ongoing changes provide a real-time look at how supernovae evolve, offering valuable lessons on the life cycles of stars. Then there's the extraordinary case of the Boat gamma-ray burst, an event so powerful it sent the most energetic light rays ever recorded our way. This burst was so bright that it initially masked any other ordinary supernova signatures. It took months for the afterglow to dim enough to give astronomers a clear view. What they found was a supernova that, while not unusually bright on its own, had thrown out material in a tightly focused jet, creating a blindingly bright beacon seen across the cosmos. Betelgeuse's changes hint at the dramatic lives of stars. The active life of Betelgeuse. These events captivate those who watch the skies and play a crucial role in our understanding of the universe. They show us how stars live and die and scatter the elements necessary for new stars, planets, and eventually, life itself to form. These dramatic celestial fireworks give us a glimpse of the processes that have shaped our very existence. Andrea Dupre, the Associate Director of the Center for Astrophysics at Harvard and Smithsonian, led a team that used the Hubble Space Telescope to take a closer look, starting their observations in early 2019. They weren't just interested in the star's surface. They wanted to explore above it, where they suspected dust clouds might play a role in the dimming. The team's research focused on the atmosphere surrounding Betelgeuse, suggesting that a cloud of dust might be partially blocking the star from view. This would make the star appear dimmer from Earth, but doesn't necessarily mean anything catastrophic is about to happen. From September to November of 2019, Dupree's team observed fast-moving particles of magnesium in the star's outer layers, speeding through space at incredible speeds of 200,000 miles per hour. This intense activity suggested that Betelgeuse is not dying, but is instead a very active, dynamic star, interacting with its own material surroundings. This could disappoint those who were expecting a dramatic supernova event. Instead, it seems Betelgeuse is just going through normal phases that many stars experience, though it's doing so more visibly due to its size and the materials it interacts with. So, the great dimming of Betelgeuse turns out to be less of a sign of an impending stellar explosion and more of an example of how stars naturally evolve and behave. It serves as a reminder that not every unusual event in the universe leads to a spectacular finish. Sometimes, it's just another aspect of how stars live their long lives, fluctuating in brightness due to various, often mundane reasons like dust clouds rather than heralding their imminent destruction. This case helps scientists and observers alike recalibrate their expectations and appreciate the regular, albeit complex, processes governing stars like Betelgeuse. As we watch the hours unfold, Betelgeuse began to behave quite oddly, dramatically shedding its outer layers. At 5:07, material from its hot, chaotic surface started spewing out into space. By 5:15, this stuff had traveled well beyond what we can see, extending millions of miles away from the star. Interestingly, as this material traveled, it began to cool off and eventually turned into dust. This is a common enough occurrence in space, akin to steam cooling down into water droplets here on Earth. Researchers observed that Betelgeuse lost about twice the usual amount of material during this 3-month episode. It seemed like the star was trying to rid itself of excess material, an event that might seem as mundane in space as spring cleaning does on Earth. Yet it's happening on a cosmic scale. At 5:41, the cause of this unusual behavior seemed to be a large plume of hot gas rising from deep within the star, much like a bubble rising to the surface of boiling water. This plume was powerful enough to push off a chunk of Betelgeuse's outer layer. This left a cooler area under a newly formed cloud of dust, which caused the star to appear dimmer when viewed from Earth. The star's light show in 2019 was so noticeable that you could see changes just by looking up from your backyard. Even the smallest details of Betelgeuse tell a bigger story. Inside Betelgeuse's fiery heart. By 2020, Betelgeuse had recovered most of its usual brightness, a bit like a celebrity making a public comeback after a scandal. By mid-February, the star had regained much of its sparkle, and by April, it looked as bright as it usually does, showing that even stars can recover from a bit of drama. Yet, there's a twist in the tale. As of early 2024, Betelgeuse was found to be spinning much faster than what seems normal for a star of its massive size. It was whirling at speeds that would make a jet fighter look sluggish, moving at about 5 kilometers per second. Observations from a sophisticated telescope called ALMA showed that one side of Betelgeuse seemed to be moving towards Earth, while the other side moved away. This odd behavior led a team from the Max Planck Institute for Astrophysics to think that what might look like spinning could actually be just the boiling surface of the star. It seems Betelgeuse likes to keep astronomers guessing, displaying behavior that adds a bit of flair to the usual stellar activities. This kind of stellar performance reminds us that even in the vast, generally predictable cosmos, there's still room for some dramatics. Betelgeuse, with its unexpected antics, shows that space is not just about cold, calculated movements, but also about some spontaneous surprises, ensuring scientists always have something exciting to observe and ponder. Betelgeuse is a young and huge star compared to others like our Sun. It rotates and releases heat and energy at an exceptionally fast rate. This means it burns through its fuel much quicker than other stars, leading to a much shorter life. Eventually, this rapid use of energy will cause Betelgeuse to explode in a massive event called a supernova. This is expected to happen within the next 100,000 years, which is soon in terms of the universe's timeline. When Betelgeuse does explode, it will be so bright that it will shine as brightly as the half moon and be visible like this for more than 3 months. The explosion will likely create a neutron star or a black hole while releasing a lot of radiation across space. However, despite the intensity of this event, it will have little effect on Earth apart from making our night skies brighter. The end of Betelgeuse will be a dramatic moment in space, demonstrating how stars, even the most massive and energetic ones, eventually run out of fuel and change. While astronomers and space enthusiasts might find this event exciting and a beautiful spectacle, for most people on Earth, it will just mean a few nights with a brighter sky. Most will notice the unusual brightness, maybe talk about it a bit, and then go on with their lives as usual, largely unaffected by the distant star's demise. This highlights how events in space, while monumental and fascinating, often have little immediate impact on our everyday life on Earth. Betelgeuse certainly stands out, but it is not the only star in our galaxy that draws attention due to its immense size. Many stars exhibit similar or even more extraordinary features. One standout example is UY Scuti, known as the star with the largest radius currently identified. This red supergiant resides in the Scutum constellation and boasts a radius roughly 1,700 times greater than our Sun. Positioned at the center of our solar system, UY Scuti would stretch beyond Jupiter's orbit. Another impressive star is VY Canis Majoris, situated in the constellation Canis Major. This red hypergiant ranks among the brightest and most expansive stars known, with a radius about 1,420 times that of the Sun. Similar to Betelgeuse, VY Canis Majoris is also on track to conclude its life with a supernova explosion. Its vast size has resulted in significant mass loss, leading to the formation of an expansive nebula around it. Other massive stars show us more about the vast universe. The reign of the universe's largest stars. Rigel, located in the Orion constellation, stands out as well. This blue supergiant is the brightest star in Orion and significantly surpasses the Sun in mass and brightness. It is about 21 times heavier and emits roughly 120,000 times more light. Rigel's intense blue hue is a testament to its extremely hot surface, which reaches temperatures around 12,000 degrees Fahrenheit. Antares, another red supergiant comparable to Betelgeuse, lies in the Scorpius constellation. With a radius about 680 times that of the Sun and a luminosity 75,000 times greater, Antares is nearing the end of its life and is anticipated to explode into a supernova. These extraordinary stars give us a clearer view into the life cycles of massive stars. While our Sun is relatively modest in both size and brightness, these supergiants and hypergiants demonstrate the vast diversity and immense scale of stars within our galaxy. The eventual spectacular supernovae of these stars are crucial for understanding stellar evolution and the dynamic activities within the universe. Their existence and transformations provide vital insights into the life and eventual demise of some of the most massive bodies in our cosmos. Starting with WR102Ka, often referred to as the Peony Nebula star, this giant resides in the constellation Sagittarius. It's not just any star, it's a blue hypergiant, one of the most massive and luminous types we know. Imagine a star so big that if it were in our solar system, it would dwarf all other celestial bodies. WR102Ka is enveloped in a thick cloud of dust. This isn't ordinary dust, though. It glows in infrared light because the star's intense radiation heats it up, turning WR102Ka into a brilliant beacon in the infrared spectrum. It's like a lighthouse whose light is seen and felt, heating up everything around it. This star is a true giant, with a mass about 150 times that of our Sun and about 100 times larger radius. HD 93129A, located in the vibrant Trumpler 14 star cluster within the Carina constellation, is a standout example of a blue hypergiant, one of the brightest and hottest stars known in our Milky Way galaxy. This remarkable star forms part of a binary system, sharing its cosmic journey with a companion star, Together, they engage in a gravitational dance, exerting a massive influence on each other and the surrounding star cluster. This interaction is akin to a stellar ballet, with each movement affecting the dynamic of the cluster. HD 93129A, an astronomical powerhouse, boasts an estimated mass of between 120 to 127 times that of our Sun. It radiates an immense amount of light and energy, significantly shaping the space environment around it. As it furiously burns through its hydrogen fuel, HD 93129A races against time, heading towards a future as a spectacular supernova, an event that will dramatically alter its celestial neighborhood. Not too far away, another cosmic giant holds court. HD 93205, also residing in the Carina Nebula, mirrors the impressive traits of its neighbor. As a blue hypergiant, its size and mass are nothing short of awe-inspiring, with a mass approximately 118 times that of the Sun. HD 93205, shrouded in thick clouds of dust and gas, adds to the mystique and beauty of the nebula. The light and energy it emits are profound, not only making it a significant beacon within the Carina Nebula, but also influencing the formation and evolution of other stars in its vicinity. This star acts like a celestial king, reigning over its court of stars, nebulae, and various cosmic phenomena, dictating the growth and development of its stellar kingdom. Throughout history, different cultures have made predictions and observations about the stars, often linking them with their myths, religious ideas, and scientific knowledge. How celestial bodies shaped ancient civilizations. Predictions played a crucial role in ancient Mesopotamia, especially during the Akkadian Empire and Neo-Sumerian Empire around the 23rd to 21st centuries BC. People in these societies thought that the stars and planets affected their futures. Their diviners or prophets would interpret events in the sky as signs. Texts from this time, like the Cuthian legend and the Curse of Akkad, show these beliefs. The Akkadian leader Naram Sin, who called himself a god, is a key figure in these stories. His failure to listen to the warnings of priests and prophets during an attack led to his defeat, which emphasized the importance of spiritual leaders in their community. Prophetic writings were common in ancient Egypt from the Middle Kingdom, 1991 to 1802 BC, to later times, 3rd to 2nd centuries BC. Important texts from the 12th dynasty, such as the Tale of the Eloquent Peasant, the dispute between a man and his Ba, the prophecies of Neferti, the admonitions of Ipuwer, and the complaints of Kakapere Somb, often talked about social and natural disasters, predicted the arrival of a hero who would save them, and critiqued social, religious, and political actions. Egyptian prophecies also talked about the reversal of social roles, a recurring theme in their stories, including the coffin texts and the Book of the Dead. The Great Pyramid of Giza, built during ancient Egypt's Old Kingdom, is known for its precise, astronomical alignment. Studies show that the pyramid lines up exactly with the cardinal directions and mirrors the belt stars of the Orion constellation. This precision suggests that ancient Egyptians had deep knowledge of astronomy, which they incorporated into their grand buildings. Some experts think these alignments were architectural successes and had deeper, possibly prophetic meanings tied to their understanding of the stars. From the 8th century BC to the 3rd century AD, Greek oracles also had a key role in explaining events in the sky. Unlike their counterparts in Mesopotamia and Egypt, Greek prophets worked independently and were highly respected for their insight. They offered advice on various issues, including political and military decisions, often saying their knowledge came from divine sources. The Oracle of Delphi is one of the most renowned examples, where both leaders and ordinary people sought guidance. In these cultures, the cosmos was seen as an area for scientific study and a source of divine messages and predictions. How a close supernova could reshape our world. These ancient groups believed that the stars and planets were closely connected to their destinies, and their interpretations of events in the sky shaped their community structures, religious practices, and political actions. If a supernova occurred relatively close to Earth, say between 30 to 100 light-years away, the effects on our planet would be quite significant. A supernova is a powerful cosmic event where a star reaches the end of its life and explodes with incredible force, releasing a vast amount of energy. If this explosion happened within that distance range, it would be close enough to have a considerable impact on Earth. Now, if a supernova exploded closer than 30 light-years, the results could be dramatic and potentially devastating. The closer the explosion, the more intense and harmful the effects would be. This is because the energy and radiation from the explosion could disrupt or damage our atmosphere, potentially leading to changes in climate and other significant impacts on Earth's environment. It could affect everything from our weather systems to the overall stability of our planet's ecosystem. On the other hand, if a supernova occurred farther than 100 light-years away, its impact on Earth would be much less severe. While we might still see some effects, such as increased brightness in the sky or minor disturbances in the cosmic environment around us, these would be far less dramatic than if the supernova were closer. The distance helps to buffer and reduce the energy that reaches our planet, making the effects more manageable and less threatening. The high-energy radiation from a supernova, which includes gamma rays and X-rays, could seriously damage Earth's atmosphere. One of the most critical effects would be the destruction of the ozone layer. With less ozone, more harmful ultraviolet radiation from the sun would reach the surface of our planet. This could cause an increase in skin cancer rates and other health problems related to UV exposure, affecting both land and water-based life forms. When a supernova explodes, it releases a massive burst of radiation followed by a stream of cosmic rays. These could ionize the atmosphere of Earth. This ionization has the potential to create more cloud seeds, which could lead to more clouds forming and possibly change weather patterns and even the climate. The increase in radiation might cause mutations in living organisms more frequently. While these mutations can sometimes lead to new evolutionary developments, they could also raise the risk of extinction for certain species. Some scientists believe that radiation from past supernovae may have played a role in mass extinctions and major evolutionary changes on Earth. The surge of cosmic rays could also make the lower atmosphere more ionized. This might lead to more lightning, which could increase fires, affecting various habitats and the balance of ecosystems. Supernovae have been observed historically, such as the events in 1006 AD and 1054 AD, which led to the formation of the Crab Nebula. These events were noted in many cultural records across the globe. However, because these supernovae were thousands of light-years away, they did not affect Earth as dramatically as a closer event might. What might lie beyond even the massive HD 93205 in the universe's uncharted territories? Like, comment, and subscribe to explore these cosmic puzzles together.